Okay, so where we're at right now is we are going to continue with mineral resources. And I think we talked just briefly the other day about this. Mineral resources. What you're going to be able to do, you're going to be able to say, I can explain what ores are and how they form. Number two, you're going to say, I can discuss a wide variety of uses for minerals. Big things right there. Big concepts. Renewable, non-renewable. I think I hit and talked a little bit about this. What do you claim as renewable? What do you claim as non-renewable? Give me an example of something that's renewable. Tyler, give me something renewable that you think you can think of. A plant. Now, that's a great example. A great example, right? Except, here's my question. When would a plant be non-renewable? Maybe. I don't know if you guys have seen, right? So, bald eagle population. Anybody know what's going on with bald eagle population? So it was an endangered species, then it became a threatened species.
I think it was like something poisonous in the water.
So there was DDT that was killing it, and it was a chemical that we used. But now the bald eagle population is going up because we are conserving, we are taking care of that resource. So there's examples of how resources can be depleted to the point past no return. The eagle is one of those stories that's awesome. Another one, alligators, right? Everybody knows there are thousands upon thousands upon thousands upon hundreds of thousands of alligators down in Florida. Back in the 40s and 50s, they were an endangered species. Nobody had seen them. What'd they do? They went back in the swamp, they made alligator babies, and now they're back. Why were they being decimated? Because of people taking their territory, people taking their land, killing them, etc. All right, renewable, non-renewable. Everybody good with resources? Petroleum. I got into a big discussion with a gal at my grandma's nursing home the other day. She said, "Oh, all this global warming stuff, it's not real." Okay, even if it isn't real, which it is, even if it wasn't real, we still have X amount of fossil fuels. We have a finite amount. This is how much we have, and I don't know how much this is, but this is all we have. If we use it, it's gone, right? And that's what's happening. All right, ore. An ore is a material or a deposit of a mineral or a metal that can be extracted. We extract ore all the time. It's called mining, right? Makes sense. Now, here's the deal. How do they form? How do they get there? Basically, it's a regional metamorphism, contact metamorphism type deal, right? And so what happens is you have minerals. Those minerals get hot. They melt. The metals melt. They then form pools according to their density, according to how much there is, right? They also are attracted to different areas by the geologic structure, right? So again, these minerals and metals and different ores, they're able to be, once cooled, extracted profitably, right? People mine them. Again, if you got it, we either grow it or we mine it, okay? Now, here's where we're at. What are some of the things that we have? Well, when we have a contact metamorphism, we see this pooling of this stuff. If it all flows together into one area and we have a large amount of it, and I say a large amount, something that can be extracted, it's a vein of whatever. So a vein of gold, a vein of lead, a vein of silver, a vein of whatever. Now, this is the beauty of that statement, because when you watch like shows and they have gold miners and the gold rush type stuff. In fact, they have a show on TV about mining for gold right now, and you hear them talk, we've hit the mother lode, right? A lode is a large vein, a very large vein. And so when they find the vein or the mother lode, that's what they're extracting. So where do we find that? Well, we find it a lot of times in different areas, but one of those areas in places where we have running water. And running water is a big thing. Now, for me, I'm sitting here trying to understand, why would water be that important? Well, it's important because water moves stuff into areas, and the more dense something is, the less it's going to move. And so the heavier materials sink to the bottom. And this is one of those situations where using density helps people find the material. And so what I want to show you is, this is how people look for gold. This would be panning for gold.
On the recreational side, people come up just to enjoy the day, or they rent a log cabin, or they can rent a camping spot, and they can stay a few days or a week. And what they do is they start out with panning. We've got different elements of the panning depending on how much productivity that they want to do, whether they just want to use a regular pan, or they want to rent one of our wheels to get a little bit more gold out, or a sluice if they want to be more adventurous to head down to the creek.
We're the McDonald's, and we're from Michigan, and we were just down south taking a vacation, and my daughter wanted to do a little bit of camping, and so we found this place and decided to do a little camping and a little bit of canning. So we're beginners at this, but so far we're pretty lucky. This is just as fun as deep sea fishing, isn't it, Justin? Oh, that's cool. Look at that. Needs a lot of luck, isn't it? Yep. Plus, it's fun while you're waiting.
We're out here at the cotton patch, the hottest spot in these neck of the woods for some gold. The sluice, using the gravity of the water, separates mineral gold, which is a heavy metal, from all the other debris, your quartz, different rocks that's within the bedrock here in North Carolina.
About 100 more years we'll have that bottle full.
This prospecting business is a pretty simple process. Due to the fact that gold is heavier than black sand, or everything that settles in there, gold's going to go to the bottom. There's nothing like a thrill, especially if it's your first time around, to pan in there and have a piece of gold pop out. It's beautiful. It really is.
So it's really quite exciting, especially when people do find gold. Now again, that's panning for gold, and then using the river with a sluice, and again using the density of gold to help you find what you're looking for. Now here's the thing though, you don't always have those kinds of situations, because like that guy in the video said, it'd take him about 100 years. This is a little bit different version of how people mine for gold, and this is more of an industrial scale.
It's the rugged frontier of the American West, boundless beauty, rich in gold. Northeastern Nevada is home to the most abundant gold field in the Western Hemisphere. 20 major gold deposits have already been discovered. Many more are likely. Technology is playing a big part in finding new sites. Steve Grusine is a geologist for Newmont Mining.
All those drill holes are surveyed for collar as well as downhole surveys, so we know exactly where that mineralization is. We load it all into the computer, we We build our shapes around that information in the computer so that when we go out and mine it, we know where it exactly is, we know where the mine has to be.
But it's not just about finding new mines, it's also about making sure the deposits are large enough to be profitable. Mining here at the Carlin property started 20 years ago. It's Newmont's largest open-pit gold mine in North America. Right now it's a mile wide by a mile and a half long and 140 stories deep. Estimates are mining here will continue for another 8 years. But the process isn't just about digging deep into the earth. The gold has to be isolated. The deeper the find, the higher the grade of ore, and the more likely it will require a complex process to separate it out. Think of it as a front-loading washing machine. Joel Lenz runs the process operations for Newmont in Nevada.
We've gone to more complex technologies, treating what we call refractory ores, where the gold is locked in other minerals, and so it's a much more complex and expensive process to liberate the gold so that we can process it and recover it.
So they're using chemicals
to extract the gold. A little more than a day
gold.
After being mined, the gold is melted and poured into molds. Each one weighs about 70 pounds. That makes each bar worth a little less than $1 million at today's prices.
$4 million,
but
$5 million.
Even though gold prices are
right
surging to record highs near $1,000 an ounce, mining companies aren't necessarily raking in record profits.
We're enjoying the benefit of higher gold prices and higher metal prices in general. We've also been through a period of very rapid escalation of energy prices and labor costs.
Add to that environmental and regulatory concerns which make opening new mines more challenging. At the end of the day, when all the gold has been mined, land reclamation has become a big part of the process. The objective? Restoring the American frontier to its original beauty. Ruben Ramirez, Reuters, Carlin, Nevada. So
there's a lot of obstacles to doing that and doing it in a sustainable method. So obviously, what are some uses of our resources? Pretty simple. Jewelry. All sorts of things. But the latest is using it for computer parts. There's a lot of gold and precious metals in computer parts. People, if it's beautiful, have been using it as a source of, it's had value for thousands and thousands of years. Think about gems and things that are precious that you can't get a lot of. It has value, and so you see even way before Egyptian time precious gems and stones being very valuable. Interestingly enough, I just saw a big article about the Vikings using calcite as a way to use it as a compass, and they're called directional crystals, and they used them when they were sailing. It was pretty interesting. So again, very good use of resources. Anything that's of value, we'll find a use for it, right? Mineral consumption, there is a finite amount. Again, I've talked about this. And so as our population increases, so does the resources and the needs for them. And so I'll give you a prime example. How many of you are wearing jewelry today? Right? A number of you. I am as well. I've got a coin that I wear on my necklace that's from 146 AD. That's 146 years after the birth of Jesus. And so we use it for money, we use it for jewelry, we use it for so many different things. Now, here's the deal. A lot of exploration going on the oceans. Another good place that they're starting to explore, they're thinking about meteorites and comets and asteroids. How do you mine those things? How about the moon, right? If we set up a base somewhere, whether it be on the moon or Mars, you have to be able to extract minerals to use for things that you're going to need them. Well, so what's the best way to preserve what we have? Conservation. Use less. Find different ways of using it. Recycle. Aluminum. Its ore is bauxite. How many of you have drank out of an aluminum can? Right? I've got an aluminum can right here. It's in my recycling. If I recycle it, it takes 95% less energy to make another can out of this can than if I go get bauxite. Guess what? We need to recycle these things. Make them into new cans. Right? So we're going to stop there. We will... you guys have done a great job.